So today we will be learning creating and using the database in Android. In this chapter we will be learning about persisting application data using the room persistence library. We will be using room to add, modify and delete the saved data. These are the basic query of simple SQL commands. Then we will be having some querying on room database, the live database. And then we will be creating the database using SQLite library. Using SQLite library, validating the database input, content values to add, modify, delete database, and many other things. Introducing the structured data storage in Android. In this chapter, in this class, we will be using the structured database of Android, that is SQLite, the relational database. We will be exploring Firebase real-time NoSQL database, the room provider, an abstraction layer over the SQLite that allows you to persist your application data using the powerful SQLite database, while abstracting away the complexity of managing the database itself. You learn how to define the room database, how to query, perform transactions using DAO, that is the data access object. You will learn how to use live data to track the changes and many other things. Storing data using the room persistence library. Room is a persistent library that simplifies the process of adding a structured SQL database to your app. Room provides an abstraction layer over the SQLite backend, making it easier to define and access the database for your app structured data while still offering the full power of SQLite. One of the challenge of adding the data to your application is creating and maintaining the object relational mapping, that is ORM. An ORM is necessary because while your application data is stored a variable within the object defined by your class, a relational database store the data in a row using the column within the table. As a result, whenever you wish to store the data in a SQLite table, you must first extract the data stored as a variable within each object and convert them into a row of values according to the columns of your table. Similarly, when extracting data from the table, you receive one or more rows of values which must be translated into one or more objects. See in this table figure 9.1. Here we have a class named as Howard. In this class, we have declared the variable as a string, Howard name, integer, boolean. We have three parameters. These three parameters will go with the object of that particular class. And this table has the same three columns and they are mapped. So this is called object relational mapping. Creating and maintaining the ORM code requires to translate between your application class data model and the relational database table. And column is one of the more error-prone, time-consuming aspect of using the relational database such as SQLite. Room simplifies this by allowing you to use annotations within your class definition. which maps the class variables to the table column and methods to the SQL statement. This section always underline the database, meaning you don't need to maintain a separate list of table and column names, or separately maintain the SQL statement for inserting, updating, deleting. Querying annotation, use SQL, avoiding the full power of SQL. Lite also allows the compiler to verify. So in this example, we will be seeing how we are adding the room persistence library. The room persistence library is available as a part of Android architecture. Component suite of library available from Google's Marvin repository. To add the room to your application, first ensure that your project build.gradle file includes the Google Marvin repository within all the project repository. So we will be adding this URL marvin.google.com to add that particular repository. Now open your application module build.gradle file. Add the following room library dependencies within the dependency node. As always, we will be implementing android.arc.lifecycle. Extension 1.1. We will be having the latest version of this. This book has an older version. Persistence room.runtime. Annotations process, the persistence room compiler 1.1, and test implementation. Now defining a room database. This database will be local in your application. The room persistence model requires you to define three components. Number first is the entity. Number second is the data access object. Number third is the room database. The entity is one or more class annotated with the entity annotation, which defines the structure of a database table that will be used to store the instance of annotated class. Data access object, all the class associate annotated with @DAO annotation that will define the method used to modify or query the database. Room database, an abstract class annotated with database annotation, extend the room database. This class is the main class, access the point for underlying SQLite connection, and must also include an abstract method that returns the data access object. The list of the entities the data will contain. This is the class. The class annotated is entities are used to define the table within the database. Each entity must include one non-nullable field annotated as primary key. Using @primary key annotation, the following snippet will create a table that includes three columns. First is Howard name, second is the Howard gold Howard, and the third is the Howard accessible. And the Howard accessibility, where the Howard name is the primary key. By default, all the public fields, these three, will be included in the table definition. You can use the @ignore annotation to indicate the field that should not be persisted. To persist the field that are accessed using the getters and setters rather than public variables, you can annotate the private variable, provide that getters and the setters use the Java beans notation, where the methods for variable foo, get foo, set foo, respectively, as shown in this listing. This is an example. This is the rest of your application, sits at the top. Then we have the DAO. Then we have the room database that communicate with this. These entities are, and these will be communicated with this class, the persistent class. Then we have the table in the SQLite database. So we have the three layers. The top, we have the rest of your application. Then this is the business logic where we are communicating with each and everything, and this is the database layer. Clear? Now we will be going for the definition and coding part. We will be continuing this in the next class.